It's over, Spider-Man! Stop this, Electro! Why should I? Soon this whole city shall belong to me!
What's happening?
Electro's draining the power lines. We need to stop him or else... Oh, hey, Black Widow, why are you here?
Stark said someone had to babysit the new Avengers.
Ah, cool. And when are they showing up?
They've already arrived.
Oh, is Thor here? Or maybe it's Ant-Man. Please don't tell me it's Wasp.
It's me.
And people say you don't have a sense of humor. I love electricity!
Let me guess. Electrical powers?
Yeah, Electro's kind of a live wire with a real shocking personality, too. Hey, save some puns for the rest of us. All right, sorry, Mr. Electro. Also, I don't control electricity.
You don't?
Of course not! I control the electro-weak force, so I can do lots of stuff. Annihilate matter, bend reality, create a sun in the palm of my hand. I think his brain's short-circuited. Last pun warning, kid.
How could you possibly do all that?
Because of particle physics. You guys know about particle physics, right?
Do I look like I know about that kind of stuff?
No, you're far too attractive.
Oh, Electro.
I don't really know either. I'm more of a classical physics, Newtonian mechanics kind of guy. Well, strap yourself in, kid, because you're in for a wild ride. Let me tell you why Uncle Electro's the strongest villain there is. Okay, so you know about atoms, right? They're tiny little things that all matter's made from. There's lots of different types of atoms. We call those elements. You can see a carbon atom here. How do we know it's carbon? Well, because it has 6 protons. Those are the little red beans in the picture. There are 6 neutrons, too. And together, they're all crammed into the center of the atom, the nucleus. Then there's even smaller particles called electrons. Those sit in orbitals, which is really just a probability cloud. We never know for sure where an electron is, and it sure as hell doesn't orbit the nucleus. That's a lie they told you in school. Atoms trading electrons is how chemical reactions happen. It's a beautiful thing. Yawn.
What was that?
Oh, sorry. I was just yawning since I already know this stuff.
That's not what you did.
Huh?
You weren't actually yawning. You just said yawn out loud like an idiot.
Okay, well, you knew what Don't sink to his level, dear.
I know, Electro. I know.
You guys are pairing up on me? Of course not! We're a triplet, just like the quarks which make the nucleons. That's right, a proton and neutron are made from even smaller particles. They come in threes, and we call them quarks. There's lots of different types of quark with wacky names, like strange and charm, but the ones that make up ordinary matter are called up and down. Not too weird, right? 2 up quarks and a down make a proton, and 2 down quarks and an up make a neutron. How am I meant to remember that? Well, if you're neutered, you're more down than up.
Excuse me?
A neutron has 2 down quarks. If you're neutered, you're more down than up. Jesus Christ, Electro. Don't take the Lord's name in vain, you little spider bastard.
Were you talking to me?
No, the spider superhero. Oh, wait a minute. Black Widow. Okay, I see the confusion. Taxonomy, am I right? You are right. There are so many particles these days that it's basically biology. Like we have a whole zoo full of them. So we came up with ways to classify them. We've got leptons, which are particles that aren't made from quarks. An electron is an example. As far as we know, it's not made from anything. Then there's the baryons, which are made from quarks. 3 quarks to be exact. Both of these are classified as a fermion, which is a particle with a half-integer spin. It's not actually spinning. That's just what we call it. There's also bosons, which have integer spin, and they include elementary particles, like the force carriers. Force carriers?
Electro, are you a Jedi?
Do I look like a goddamn Jedi?
You kind of look like a duck that threw up over itself.
Well, that's one less Christmas card I'll be buying this year. Okay, but midichlorians are one of the force-carrying particles, right? No, midichlorians aren't a bloody particle, you bloody ninny.
Electro, please don't use the N-word.
Look, these are the force carriers. We've got 4 fundamental forces of the universe, right? Gravity, the weak force, electromagnetism, and the strong force. Now, you've probably only heard of 2 of these, gravity and electromagnetism, but they're all important. The weak force is why our sun burns, and the strong force is why protons in the nucleus don't electrostatically repel one another. Without it, we'd be dead.
This guy's got a real hard-on for forces.
Did you say hadron?
No.
Because hadrons are also a family of particles. We didn't cover that earlier, but baryons are hadrons, which means so are protons and neutrons. The Large Hadron Collider at CERN fires them at each other. It's basically a multi-billion-dollar hadron torture chamber. Can we please stay on topic? Certainly. Forces are transmitted through the universe via particles. Photons are the carrier of the electromagnetic force. Gluons carry the strong force. W and Z bosons the weak force. And gravitons are for gravity. Though gravitons are just hypothetical. We've never actually observed them.
Kind of like how I've never actually observed Spider-Man having money.
That is both correct and true. You can see the range and the strength of the forces here, too. Gravity and electromagnetism have infinite range, which is why we experience them so much. And gravity is actually the weakest by quite a bit. It seems counterintuitive to us, but trust me, the force gluing the nucleus together is way stronger than that. I guess it's called strong for a reason, right? Oh, Mr. Electro, you're so witty.
Well, thanks. I think I might have learned something today. Let's head back, Spidey.
I sure hope Mr. Stark's making us special brownies tonight.
You really shouldn't be eating those.
Head back? What are you talking about? I haven't explained why I'm the strongest supervillain yet. Didn't you?
I feel like you've been talking for ages.
No, this is just foundational stuff. Now I can really start impressing you. Behold! Holy shit, did he just turn that thing into gold?
I think I might have a new best friend.
Remember those quarks we talked about earlier? Well, the weak force is able to flip them. It can turn an up quark into a down into an up. And at high enough energies, the weak force and electromagnetic forces are unified. They become the electro weak force. They are deeply connected. After years of practice, I have mastered the weak force. Hey, could you make more of that gold?
Less yappin', more zappin'.
An electricity pond, Black Widow? Really?
I apologize.
Well, at least tell us how you did it. Well, it was pretty simple, actually. So I had some lead, right? It's got 82 protons, and gold's got 79 protons. So all I had to do was turn 3 of lead's protons into neutrons by flipping one of their up quarks into a down quark. Lead's proton number decreases by 3, and its neutron number increases by 3. So its atomic mass remains the same, but since it has 79 protons, it's now gold. Damn, he getting all Edward Elric on us.
Deep cut, Spidey.
A proton turning into a neutron is a type of beta decay. It requires energy, since a neutron is slightly heavier than a proton. When you do it, you also get a positron and an electron neutrino. Those are more particles. There are loads.
Not bad, Electro. But what about when you change a neutron into a proton?
Going straight for the goods, Widow? Love it! I need an adult. This is another type of beta decay. It's very similar to before, but in this case, the extra particles we get are an electron and an electron antineutrino. They're the antiparticles of the two we got earlier. It's like poetry. Hey, this particle physics stuff is kind of fun. Thanks, Electro. Don't mention it, kid. And I didn't even put you in crippling lifelong student debt. That sure is nice.
Guys? Why has the gold started sizzling?
Oh, that's because it's radioactive.
It's what?
Earth to Widow, anyone home? It's radioactive. Haven't you been paying attention? I turned 3 of lead's protons into neutrons. Yeah, and you made gold? Yeah, I made gold, an isotope of gold. Gold's only meant to have 118 neutrons, kid. Lead has 125, and I flipped 3 of its protons into neutrons to make gold. So the gold we got has 128 neutrons. That's 10 more than it should have. Its nucleus isn't stable. It's radioactive.
Did you just give me cancer?
Probably not, but maybe. You're really starting to amp me up. Excellent pun, kid. I'm so conflicted.
But why is it sizzling?
So I turned stable lead atoms into gold 207, right? Now, generally, things want to get into a lower energy state. Think of a ball on a hill. You give it a push, and it rolls all the way down. Well, the same sort of thing happens in gold 207's nucleus. It knows it can get into a lower energy state if the weak force flips one of its neutrons back into a proton. And hey, we have a word for that. Beta decay. Our proton number increases from 79 to 80, which means the gold isotope becomes a mercury isotope. Now, when this happens, the nucleus can sometimes get a little excited. And in that case, it emits a photon to release some of the energy. That photon is a gamma ray. It heats moisture, ionizes air. That's the sizzling. Mr. Electro, that doesn't sound so good. Yeah, gamma rays are super dangerous. Lots of energy and highly penetrating. I'd probably put that gold down now. But hey, it's not all bad news. That unstable gold isotope will eventually decay back into a stable lead atom. Here's what the full process looks like. 3 neutrons were flipped into protons. The gold isotope flips one of its neutrons back into a proton, so now we have an isotope of mercury. Then the mercury isotope does the same thing, giving us an isotope of thallium. And we've got one final beta decay to turn that back into stable lead. These aren't random elements, by the way. They all sit right beside each other on the periodic table. Nature sure is clever, right?
You're insane!
Gee, what's grinding her gears? I think she's upset that she's the weakest Avenger. Well, maybe those gamma rays will fix that, huh? Please, God, don't give us another season of She-Hulk.
Just how dangerous was that thing?
Great question. Radioactivity is equal to ln2 over half-life times n. Radioactivity is measured in becquerels, or seconds to the -1. Half-life is how long it takes for radioactivity to fall to half of its original value, and n is the number of radioactive atoms. For 10 grams of the gold 207 isotope with a half-life of 1 day, its radioactivity is 2.3 times 10 to the 17th decays per second. That's 230 quadrillion. That's a pretty big number, but you didn't really answer her question. I'm getting there. Have some patience.
You sound like Spider-Man speaking to his landlord.
I always knew he was a broke bitch. Nat, stop embarrassing me in front of Electro. The power output is equal to radioactivity times energy released per decay. Let's assume each decay emits 1 mega electron volt of energy. Then using the radioactivity from earlier, we calculate the power to be 37 kilowatts. That's comparable to a small car engine from just 10 grams of gold 207.
Impressive, but it's an engine which is constantly getting weaker as the isotope stabilized. I'm not impressed.
You just said it was impressive.
I was lying.
Oh, she's good. Black Widow's an untrustworthy backstabbing assassin.
You're making me blush.
And her most popular design was introduced in The Amazing Spider-Man back in 1970. Yeah, you guys probably thought it was weird for me and Black Widow to team up today, huh? I've been tapping that for over 50 years.
Excuse me!
So, anyway, without the weak force, we'd all be dead. It's essential for the nuclear fusion which occurs in the sun. The sun is a giant burning ball of plasma. There are protons floating inside it. The first step of the process is when 2 of these protons fuse together. One of the protons is flipped into a neutron, and together they form deuterium, an isotope of hydrogen. Then deuterium fuses with another proton to form a helium-3 isotope. This is the important step for us as it emits a photon, which is the light that gives us all life. The final step is when 2 helium-3 isotopes fuse to make a stable helium nucleus, also known as an alpha particle. That's pretty cool, right, Black Widow?
Ugh, don't talk to me.
Well, I thought it was cool. It's kind of a lot, though. How's anyone meant to remember all that? Luckily for you, we can summarize the overall reaction with one line. 4 protons are converted into an alpha particle, 2 positrons, 2 neutrinos, and a bunch of photons. It actually takes up to 100,000 years for the photons to escape the sun's core. They start off as gamma rays, very high energy, but the journey to the sun's surface causes them to lose energy, so they become ultraviolet, visible light, and infrared. This is why we can see the sun shine. Those photons spend 100,000 years learning to walk, 8 minutes to cross the void of space, and the first thing they touch is your face.
Electro, that was beautiful.
And I can make one in the palm of my hand to nuke someone!
You, what?
I can easily create deuterium or even tritium from just tap water or air humidity. I can control the weak force, so why not? Instant nuclear fusion fuel. Then all I need to do is confine the fuel using magnetic fields to raise its temperature, which I can do, by the way, since electricity and magnetism are basically the same force. You know, a moving electric current creates a magnetic field, and a changing magnetic field creates electricity. You guys know that, right? Yeah, we watched the Magneto video. Great! So yeah, sun in the palm of my hand. Most of the energy in my little microsun is in the form of a high-energy neutron blast. That penetrates shielding and irradiates everything, by the way.
Humble brag much?
I have very few friends.
Have you considered not being evil?
Never! Okay, well, I admit you're pretty tough, but even Doc Ock could do the whole sun thing. You're gonna have to try a little harder to be the strongest villain ever. Spider-Man, you patronizing little fool! Don't you know I've saved my most devious power for last? You have to be so mean. Antiparticle annihilation. We've seen antiparticles before, like the positron that's made during beta plus decay. A positron is the antiparticle of the electron. It's a mirror copy of the electron. Same mass, spin, force strength, but their charges are flipped. Positron is positive, electron is negative. And when a particle meets its antiparticle, they annihilate each other.
Kind of like how Spider-Man's life was annihilated after his uncle died.
Widow, what the hell?
Hey, you said some pretty weird stuff about me earlier.
Okay, fair enough. Hey, wait a minute. How did you know my uncle died?
It was me, Peter.
No, that can't be true. That's impossible.
I debuted as a villain for 2 years from 1964 to 1966. It was me!
So, yeah. When a particle meets its antiparticle, they both, explode and stuff. The energy released from this is actually catastrophic. The entire mass is converted to energy. We know that E equals mc squared, and in this collision, the total energy is 2mc squared, since the particles weigh the exact same. If we had just 1 gram of matter and 1 gram of antimatter, then the energy produced would be 180 trillion joules. That's the same as the kinetic energy of a large asteroid. A large asteroid! And just 1 gram of this stuff! Ha! No wonder it's heavily abused in science fiction. That's pretty cool, but how can you weaponize it? You can't pluck particles and antiparticles out of thin air, right? It's true that the weak force can't just flip particles into antiparticles. That would break conservation laws. But if 2 photons collide with high enough energy, then they can turn into an electron-positron pair. As you already know, photons are the force carriers of the electromagnetic force, which I have complete and total control over. So yeah, I can make 2 photons collide, which means I can make electrons and positrons, so I can totally weaponize this. Hell, I could flood your body with just positrons and have them annihilate you from the inside out. Okay, well, I gotta go. Hey, what's wrong? Don't you want to hang out? Nah, man. You're kind of scary.
And weird.
And cartoonishly evil.
And weird.
Oh yeah, and also weird. Okay, well, at least take my card. You've learned a lot today, and I wouldn't want you to forget why Electro is the greatest supervillain there is.
I'm not keeping this.
Please be my friend.
No.
Please, Black Widow. Please. I'll be your friend. Screw you, Spider-Man.